Hi students, now we are going to study a new chapter, lines and angles. Let us see some basic terms. The first term is length. Length that moves indefinitely on both sides and that cannot be measured. It is denoted by AB. Then what is line segment? Line segment is the part of line that can be measured, denoted by AB. Then what is ray? It is the part of the line having one endpoint. It is denoted by AB. What are collinear points? If three or more points lie on the same line, then the point should be collinear points. What are non-collinear points? If three or more points that do not lie on the same line, then the points are non-collinear. What are angles? Two rays meeting at a common point form an angle. Let us see types of angles. The first type is acute angle. Acute angle measures between 0 degree and 90 degree. Then what is right angle? Right angle is exactly equal to 90 degree. Here is the figure. Obtuse angle. An angle greater than 90 degree but less than 180 degree is called an obtuse angle. That also shown in the figure. What is straight angle? Angle is equal to 180 degree. Then reflex angle. Angle which is greater than 180 degree but less than 360 degree. Complementary angle. Two angles whose sum is 90 degree are called complementary angle. Then supplementary angle. Two angles whose sum is 180 degree are called supplementary angles. Then adjacent angles. Two angles are adjacent if they have a common vertex, a common arm, and their non-common arms are on different sides of the common arm. Linear pair of angle. Two angles are said to be linear if they are adjacent angles formed by two intersecting lines. Vertically opposite angles. The angles formed when two lines intersect each other. Intersecting lines and non-intersecting lines. Both figures are given below. The lengths of the common perpendiculars at different points on these parallel lines is the same. This equal length is called the distance between two parallel lines. Then pairs of angles. From the figure, if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degree. When the sum of two adjacent angles is 180 degree, then they are called a linear pair of angles. We have concluded that the sum of two adjacent angles so formed is 180 degree. Statement A. If the sum of two adjacent angles is 180 degree, then a ray stands on a line, that is, the non-common arms form a line. Both the non-common arms lie along the ruler, that is, points A, O and B lie on the same line and ray OC stands on it. Also see that angle AOC plus angle COB, that gives 125 degree plus 55 degree, that gives 180 degree. We may conclude that statement A is true. Then we are going to see linear pair axiom. If the sum of two adjacent angles is 180 degree, then the non-common arms of the angles form a line. For obvious reasons, the two axioms above together is called the linear pair axiom. Let us see a theorem. Theorem 1. If two lines intersect each other, then the vertically opposite angles are equal. Here is the proof. In the statement above, it is given that two lines intersect each other. So, let AB and CD be two lines intersecting at point O as shown in the figure. They lead to two pairs of vertically opposite angles. Namely, first one is angle AOC and angle BOD, and the second one is angle AOD and angle BOC. We need to prove that angle AOC equal to angle BOD and angle AOD is equal to angle BOC. Now, ray OA stands on the line CD. Therefore, angle AOC plus angle AOD, which is equal to 180 degree, because linear pair axiom. Can we write angle AOD plus angle BOD is equal to 180 degree? Yes. From the equation 1 and 2, the first equation is angle AOC and angle BOD and the second equation is angle AOD and angle BOC. We can write from this both equation angle AOC plus angle AOD. That gives angle AOD plus angle BOD. This implies that angle AOC is equal to angle BOD. Similarly, it can be proved that angle AOD is equal to angle BOC. Now, let us do some examples based on linear pair axiom. First example. In this figure, ray OS stands on a line POQ. Ray OR and ray OT are angle bisectors of angle POS and angle SOQ respectively. If angle POS is equal to x, find angle ROT. Let us solve the problem. Ray OS stands on the line POQ. Therefore, angle POS plus angle SOQ is equal to 180 degree. But angle POS is equal to x. Therefore, x plus angle SOQ is equal to 180 degree. So, angle SOQ is equal to 180 degree minus x. Now, ray OR bisects angle POS. Therefore, angle ROS is equal to half into angle POS, which is equal to half into x. That gives x by 2. Similarly, angle SOT is equal to half into angle SOQ. That is equal to 1 by 2 into 180 degree minus x, which is equal to 90 minus x by 2. Now, angle ROT is equal to angle ROS plus angle SOT. That is equal to x by 2 plus 90 degree minus x by 2, which is equal to 90 degree. Can we move to next portion? Parallel lines and a traversal. The line which intersect two or more lines at a distinct point is called a traversal. Here is a figure. From the figure, line L is a traversal for lines M and N. Observe that four angles are formed at each of the points P and Q. Then corresponding angles axiom. If a traversal intersects two parallel lines, then each pair of corresponding angles is equal. It is also referred to as the corresponding angles axiom. If a traversal intersects two lines such that a pair of corresponding angles is equal, then the two lines are parallel. Does this statement hold true? It can be verified as follows. Draw a line AD and mark points B and C on it. At B and C, construct angle ABQ and angle BCS equal to each other as shown in the figure. From the figure above, we can infer that produce QB and SC on the other side of AD to form two lines PQ and RS. The two lines do not intersect each other. Then the common perpendiculars to the two lines PQ and RS at different points and measure their lengths. We may conclude that the lines are parallel. Therefore, the converse of corresponding angles axiom is also true. Then, lines parallel to the same line. It occurs when if two lines are parallel to the same line. Line T traversal for the lines L, M and N. It is given that line M parallel to line L and line N parallel to line L. Therefore, angle 1 equal to angle 2 and angle 1 is equal to angle 3 because corresponding angles axiom. So, angle 2 is equal to angle 3. But angle 2 and angle 3 are corresponding angles and they are equal. Therefore, you can say that line M parallel to line N. This result can be stated in the form of the following theorem. The theorem states that lines which are parallel to the same line are parallel to each other. Let us see an example. If a traversal intersects two lines such that the bisectors of a pair of corresponding angles are parallel, then prove that the two lines are parallel. Solution. Given a figure. From the figure, a traversal AD intersects two lines PQ and RS at points B and C respectively. Ray BE is the bisector of angle ABQ and ray CG is the bisector of angle BCS and BE parallel to CG. We have to prove that PQ parallel to RS. It is given that ray BE is the bisector of angle ABQ. Therefore, equation number 1, ABE is equal to half ABQ. Similarly, ray CG is the bisector of angle BCS. Therefore, equation number 2, angle BCG is equal to half angle BCS, but BE parallel to CG and AD is the traversal. Therefore, equation number 3, angle ABE is equal to angle BCG. Substituting equations 1, 2 and 3, we can get half angle ABQ is equal to half angle BCS. That is, angle ABQ is equal to angle BCS. But they are the corresponding angles formed by the traversal AD with PQ and RS and are equal. Therefore, PQ parallel to RS. Angle sum property of a triangle. The sum of all the angles of a triangle is 180 degree. This statement using the axioms and the theorems related to parallel lines. Here is an example. In this figure, if QT, angle PR, angle TQR is equal to 40 degree and angle SPR is equal to 30 degree, find X and Y. Solution. In triangle TQR, 90 degree plus 40 degree plus X is equal to 180 degree. Therefore, X equal to 50 degree. Now, Y is equal to angle SPR plus X. Therefore, Y equal to 30 degree plus 50 degree. That gives 80 degree. Now, let us summarize. If a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degree and vice versa. This property is called as the linear pair axiom. Then, if two lines intersect each other, then the vertically opposite angles are equal. The next point is, lines which are parallel to a given line are parallel to each other. Then the next point is, the sum of the three angles of a triangle is 180 degree. Then, if a side of a triangle is produced, the exterior angle so formed is equal to the sum of the two exterior opposite angles.